Have you ever wondered what really makes your computer feel so snappy, so responsive? It's not just about having a powerful processor. There's actually a brilliant, almost invisible system working behind the scenes. So today, let's dive into that hidden architecture that makes all of modern computing possible. It's called the memory hierarchy. To get our heads around this, we have to start with a fundamental question, a puzzle that every single computer engineer has to solve. When you're designing memory, what's most important? Do you want it to be unbelievably fast? Absolutely massive, or super cheap? And here's the thing, you can't have it all. It's the classic engineering trade-off, right? Fast, good, or cheap? Pick two. You can get fast and big, but it is not going to be cheap. Or, hey, you can get big and cheap, but it definitely won't be fast. This one simple constraint really shapes the design of every digital device we use today. So we're basically stuck between these two extremes. On one side, you've got memory that is just lightning fast, but it's tiny and it costs a fortune. On the other side, you've got memory that's huge and super affordable, but it's painfully slow. So the real question is, how do you build a computer that feels like it has one giant, super fast pool of memory without completely breaking the bank? Well, the solution is actually pretty clever and surprisingly intuitive. The best way to think about it is to imagine a well-organized kitchen. Let's say your computer's a chef, and its job is to cook a meal as fast as it possibly can. Well, where it stores the ingredients is everything. So first up, right there on the countertop, literally within arm's reach, you've got the essentials. Your salt, pepper, olive oil. These are the things you're using all the time. Access is instant. But the space is super limited, right? You can't keep your entire grocery haul here. Okay, so a few steps away, you've got your pantry. This is where you keep the stuff for this week's meals. The pasta, the canned goods, the spices. It's a lot bigger than the countertop, and yeah, it takes a second longer to go grab something, but it's still really accessible. And then, way down in the basement, you have this massive warehouse. This is where you're storing the bulk supplies. Huge sacks of flour, cases of water. You've got tons of space, but wow, it is a real trip to go all the way down there to get something. It's way too slow for that moment-to-moment cooking. So this whole system, the countertop, the pantry, the warehouse, that is exactly how a computer manages its data. We call it the memory hierarchy. It's this brilliant pyramid structure designed to give the processor the illusion of having one single giant and incredibly fast memory to work with. All right, so let's swap out our kitchen stuff for actual computer parts and take a quick tour of these layers, starting at the very top of the pyramid, the stuff closest to our chef, the CPU. Our countertop, that's the CPU cache. This is, without a doubt, the fastest, the smallest, and the most expensive memory in the entire computer. It holds the data and the instructions the processor is working on right this second, or what it thinks it's going to need in the very next instant. And when I say these are extremes, I mean it. The speed is, well, it's practically instantaneous from the CPU's point of view. But the size? We're talking tiny amounts, like megabytes, not gigabytes. And the cost for every single byte is just astronomical compared to anything else in the system. Okay, one level down, we find our pantry. This is the system's RAM, or random access memory. Think of this as your computer's main workspace. When you open an app, or you load a big file, or browse a website, all of that data gets loaded into RAM. Now, RAM is all about balance. It's way bigger than the cache. Now we're talking gigabytes, and it's a whole lot cheaper. But it's still plenty fast enough to keep up with what the processor needs most of the time. It really is the workhorse of the whole memory system. And finally, at the very bottom of our pyramid, we've got that giant warehouse. This is your permanent storage, your solid-state drive, or your hard disk drive. This is where all your files, your operating system, your games, everything lives when it's not being used. Now, compared to RAM and cache, storage is slow, like really slow. But the trade-off is totally worth it, because its main advantage is massive capacity for a really low cost. We're talking terabytes of space where you can just store your entire digital life for years to come. And this table just lays it all out perfectly. As you go up that pyramid from storage to cache, the speed goes way up, the cost per byte goes way up, but the size gets much, much smaller. And that kitchen analogy, it just lines up perfectly, giving you a really powerful way to picture how this whole thing fits together. So, we've got these different layers, but how do they actually cooperate to give us that fast, seamless experience? Well, the magic is all in how data moves between them. It's a really simple, logical flow. The CPU, our chef, needs an ingredient. The very first place it looks is the countertop, the cache. If it's there, perfect. That's a cache hit, and it's super, super fast. If not, okay, it checks the pantry, the RAM. If it finds it there, it uses it, but, and this is the really clever part, it also brings a copy up to the countertop, basically guessing it might need it again soon. And only as a last resort, if it can't find it anywhere else, does it make that long, slow journey down to the warehouse to storage. And this constant, intelligent shuffling of data, that's the real secret sauce. That's why our computers feel so quick. It's why apps can switch in the blink of an eye, even though most of our computer's memory is actually, relatively slow. And let's just put a number on that. Getting a piece of data from the CPU cache can be over 100 times faster than fetching that same piece of data from RAM. Get that? 100 times. By being smart and predicting what data to keep on the countertop, the system manages to avoid that much slower trip to the pantry, something like 90% of the time. It's incredible. So if you take one thing away from this, it's this. The memory hierarchy isn't just some neat feature, it's the foundational trick. It's the invisible engine that makes everything else go. It creates this beautiful illusion of a single, huge, super fast memory. And that's what gives us the performance we've come to expect when we're, editing a video or loading a massive game. And that kind of leaves us with a fun question to think about. As the amount of data we're all creating just continues to explode, we're talking giant AI models, 8K video, computer architects are always trying to rethink this pyramid. So, what do you think? What will the next layer in our digital kitchen even look like?